Hi, my name is Kraai. You might know me better as Kraai the Comedian, Kraai Du Toit.
Gentlemen, welcome to the stage, all the way from Pretoria, Kraai Du Toit!
I am also an avid software developer and solutions architect, and in this series, I am Kraai the Coding Guy.
Welcome. Today we're talking about Azure API management, and to be more precise, Azure API management on a container. The problem we have currently is providing a unified API management everywhere. As most API managements today, they run on clouds and public clouds. As an example, Azure API management runs on Azure Microsoft. While having a purely based client API management service can work for almost any scenario, there are other scenarios where it's not necessarily the best choice. Running API management solely on one cloud does have some problems. It does have limitations. All the requests coming from backend applications and data go through the cloud that provides the API management service. For applications and data located in the cloud as the API management service, this is fine because they need to use that access the cloud anyway. But what about other applications that are not located on the cloud? What if a client is accessing on-premise applications and data within the same corporate environment, but none of the traffic is allowed to leave the environment? When a client accesses applications and data in public cloud, why pay for the data twice? If the client and the backend service are in the same environment, such as when they are both on premises, why incur the delay of going through a public cloud for API management? Now, self-hosted API management gateways can address that limitations. The benefits of having an API management on a container is quite simple. The Azure API Management self-hosted gateway extends support for hybrid and multi-cloud scenarios and enables you to manage distributed API environments from a central API management instance at Azure Central. You can do this in the Azure portal itself, and then managing it even off-site. I'll explain a little bit later. As the API management is off-site, it can check for settings on-site, but once it's ready, you can export it and you can host it on your on-site on-premise container. Running a self-hosted API gateway in your on-premises data center can be very beneficial. Running a self-hosted API gateway in another cloud can also be beneficial. You can take that same container that has the gateway and move it to AWS, to Google, or Alibaba Express. Self-hosted gateways, which is fully equivalent to the managed API, is packaged as a Docker container, meaning you can run it anywhere. You have a consistent API experience, as the Azure architecture for API management enables companies to provide API consistency to their consumers. A win-win and another win scenario. 3 wins. Not even the Springboks could get it right. For an API consumer, operations and development teams. Federated with API management in the cloud, the self-hosted API gateway will automatically pull down any new configuration deployed to the managed gateway in Azure and push its telemetry up. No inbound ports required, only outbound, and no local storage required to maintain configuration data. There's another benefit. As a developer, this truly improves my experience. It's not the main reason why the self-hosted gateway was made, but being able to clone an API, configure an API on a local self-hosted gateway and develop and test policies locally without interfering with any other team members is definitely a bonus. A gateway in Azure API management resembles a logical gateway with which you can deploy multiple nodes where you want. This image displays a setup with a single node. As we can see in the top image, we will see the clients, an on-premises gateway with self-hosted and our APIs. And then on Azure, it will use the same, but then it will go through the Azure API management on Azure. We also have the benefit of shared responsibilities. Self-hosting a gateway also means taking away some responsibilities from Microsoft and pulling it into your own hands. This can be a negative or a positive, depending on what you want to do. Let's have a look at the overview below and get an idea of the separation of responsibilities. On Microsoft's side, the managed plane of is the SLA. They manage the whole entire SLA. They manage the gateway maintenance and they manage the gateway updates. On a self-hosted gateway, however, you manage the gateway hosting. You manage the network configuration, the network SLA, and keeping the gateway up to date. You also need to provide diagnostics and data support. This, however, is not a bad thing if you want to do it on a locally or in your domain for development purposes and SIT before going live. You also benefit from some of the other benefits of a cloud API. Example, documentation, rate limiting access, health monitoring, formats. In other words, you can export it to XML, JSON, CSV, connections to APIs. Connections to APIs is quite simple with the Azure gateway. Combining APIs into one single API for better customer performance. You can also connect it to analytics as well as the security with tokens and any other security you want to build into the gateway. Now let's look at how you set up an API gateway to run on a container. First, you go into your Azure portal and find API management. In the top, you can search for API management. And once you see this little logo, just click on API Management Services. If you don't already have one, create one. I am not going to walk through the creation of this as this takes about 30 minutes. I've already created a local gateway test for us here. And you can see on our APIs, the current API is the default API provided by Microsoft. There's a lot of settings in API management that you can use that I'm not going to go through all right now, but something that is nice to know is that there is external cache. If you want to cache the API management and the calls, and all of the access, named subscriptions, products, workbooks, there's quite a lot. For our purposes, we are going to create a single API that is hosted on premises and create a gateway that links locally to run a local gateway of our API management system. On our local system, local network, we're using a product called Rancher to host all our images and run our containers. So if I want to look at this following microservice, we find its JSON file, which is quite important. We save the JSON file as this is OpenAPI. Save it in a relevant folder. Then go to API management. Choose OpenAPI. And a little tip, choose full. Once we have the full, we can select the file and you browse for the file that you want. And now we can set up the API. It is quite important to note that you need to set up an actual product for this API to work. So in our products, we've got unlimited and starter. Choose unlimited. You can later set up the product you want. Please note you can also version this API, but for our demo purposes, we won't version this API. For my purposes for this demo, I've decided to call the namespace for our API create that contact in place. Okay, so as you can see, when we add a prefix, we add a prefix to the actual gateway URL. And that's it. Now our actual API is being created. Press create and wait. Okay. To see that this actual API is now linking to the on-site and not an internal gateway, we look at the URL address we have here. This is our internal URL address. As you'll see, it pulled through the entire function set of our API based on the Open API settings. That's all we need to do from here. Next step, now we're going to containerize this app. On the side of API management, you'll find gateways. Click on gateways, click add a gateway, choose a name for this gateway. We're going to call this contact place. And on-prem, which means this is on premises. You're going to choose a location. And we can choose a description. At the bottom there's a little plus sign. This little plus sign is a little bit sticky, so just be patient. Click on it once and you'll see our APIs that's being added. We can add multiple APIs in this gateway, but for our purposes let's just add the one that we created. Click add, and now our gateway is created. Once our gateway is created, it's quite easy. We go into the gateway, we look at deployments, and we'll find that there's an actual configuration file and a Docker run file run here, as well as how to set it up on Kubernetes with a proper YAML file for all your deployments. For our purposes, we're going to just show how it's running on Docker. Okay, so we're going to copy this file, open a new notepad, save that Docker file over there. In my case, port 80 is already taken, so I am going to go with port 82. If you don't know how Docker works, well, maybe try and learn it. I will not have time to explain Docker in this video, but in maybe future videos we'll have time to explain Docker. Okay, so that is our API management there. Next thing we need to do is take this environment variable file. This environment variable file will actually tell us exactly what we need. You'll see there's an endpoint in there which tells us the endpoint of the API management on Azure. This as well also tells us the resource group and the provider, plus an API version it's already created for us. Then it will tell us what API gateway it's using that we just set up, and this GUID, which I presume is an internal GUID for our API keys here. So if we go back to deployment, we need to save this environment file. Microsoft is kind enough to give us that option by clicking on that file and going to a folder. Save this in the folder that you're going to run your Docker file. If we now go to that folder, you'll see there's our file being created, plus our original local API we saved, and we can right click, shift, and open PowerShell, taking us directly to that folder. Once you're in the folder, we can run our Docker file. Now, the reason we run it in this folder is because we need that environmental file to be pulled in. Ooh, we already have a port allocated for port 82. So in my case, let me just stop port 82, remove that one, and now it should be good to go. What? Still not. Okay, this was port 443 that was giving the issue. Okay, so now it's running perfectly. You might run into some of those issues. So there is our contact in place running. If we open Docker, and to get to this, you can open Docker, you can go dashboard, and you'll see, just give it a second, you'll see there is our new contact in place. Now we can run this in the browser, and we'll get that part. Now remember, we gave the namespace of this, and we can actually run this in Rancher to see if we do get any values. So if we run this in Rancher, and we go to our values there, we'll find for this specific person, we'll find some values in our contact in place. Now we want to test this specific value inside our API. Now remember, we did give it a namespace as before, and to run this, we need to get that API namespace. If you don't remember, we added the namespace when we added our API right in the beginning here, which can be seen in the settings when we deployed it. So when we run this, we will get an error. We will get an error saying access denied due to subscription key. In order for us to run this, we need to add a subscription key in the header. So I'm going to open my Postman, copy the same command over. In my headers, I need to add a subscription key. To find our subscription key, we go to the subscriptions, and you'll see there are keys here. For our unlimited product we chose, we can reveal that key by clicking on the dots, show hide, get our primary key, copy that key. That key must have a value called OCP APM subscription key. I'm copying this because my memory is really bad. I don't remember this. Sometimes I don't even know what my own name is. So right now, that's why I'm copying this. If we run the same command now, we should get values being returned. And there's our values being returned. Now, for security purposes, we could also add, because we don't have a bearer token, but just like normal APIs, we can now add other security methods like bearer token, username, password, keys, combining APIs, and this is running locally, pulling the values from our rancher on our local on-prem environment.